Okay, here's the solutions for the coordinate geometry test. Alright, let's start with a multiple choice. So what we've got is a line passing through 3, 4 and negative 2, 14. And what we want to do is find out which one of these points is actually on the line. Now, there's a fairly easy way to do this problem. Doesn't work for all questions, but when you've got nice whole numbers, it is really easy. Alright, let's do table of values. Negative 2, negative 1, 0, 1, 2, 3. Alright, when x is negative 2, y is 14. When x is 3, y is 4. Well, what are the gaps between? I've got 5 numbers, goes down by 10 between 14 and 4, so that means the gradient must be negative 2. 12, 10, 8, 6. Right, so it checks out. So we've got a gradient of negative 2, and lo and behold, have a look at this. 1, 8 is there. So it goes through that point. Now, I prefer that method of doing it, but some of you are going to need to go the longer way around and calculate the gradient and then calculate the y-intercept of this. So let's do it the longer way. So we've got 14 take away 4 over negative 2 take 3, that is 10 on negative 5, that is negative 2 as the gradient. Okay, now if I know that y equals negative 2x plus c, I'm just going to choose the easiest point and sub it in here. So I've got 4 equals negative 2 times 3 plus c, 4 equals negative 6 plus c, c equals 10. So our equation is y equals negative 2x plus 10, and we know that this is the answer, but what you'd have to do this long way here is test out all of these points. Okay, we know that this is the answer, but let's prove it. I'm going to sub that coordinate point into this relation. If it's true, left side and right side should be exactly the same. 8 equals negative 2 times 1 plus 10. 8 equals negative 2 plus 10. Oh my goodness, 8 equals 8. Okay, and so we've just confirmed that that point is on the line. Next question, and what we've got is a families question here, and these ones look challenging. They're a bit in a bit of an unusual form, but this one here is not really that difficult. Alright, so what we're looking for here is we've got a family of functions, a family of graphs, and that varies. That means that's going to stay the same. That's what they're all going to have in common. They all go through a y-intercept of negative 3. So it's pretty easy. We're looking for one that doesn't have that situation. It's not the family member. And it's actually this answer here. How do I know? Let's transpose it. 3x plus y equals 3. Y equals negative 3x plus 3. Alright, look at the y-intercept. Goes through positive 3, not negative 3. Therefore, sorry, not in that family. Alright, question 3. Family of lines are given by the equation y equals mx plus 5. Okay, so m is the parameter, plus 5 is what all the family members will have in common. And for what values of m will the family of lines not intersect at all with this particular line here? Well, I know it's when the gradient of this family is exactly the same as this line here, because then they'll be parallel and therefore never intersect. So it's easy. What we're going to do is grab the gradient of this line here, and that will be when this one, when m is that number, it won't intersect. So let's transpose. Y equals negative 2x plus 3. The m, or the gradient of that, is m equals negative 2. So that's when this is negative 2. Okay, when m is negative 2 over here, it won't intersect. So it's that answer there. Alright, going down here, what we're going to look at for this linear relation, we've got a few things we're going to do. We're going to find the equation, transpose it, and then calculate the midpoint. Alright, so let's grab the equation. Now, I like to do things the quick way, but with this one, there really isn't any. What we're going to do is grab m by doing y2 minus y1 over x2 minus x1. The reason we're going to have to go the long way is because I'm not so good at guessing gradients with fractions, and I'm also not going to really take a chance on what might be 3 as a y-intercept, but it might be 3.1, I don't know. Anyway, so let's go the whole way around and work it out. Alright, so we've got x, y, x, y. Okay, and we're going to do 7 on 2 subtract 1 all over, what are we doing? 1 subtract -4. Alright, that's 7 on 2, take 1 over 1 plus 4. Alright, now this one here, what I tend to do with fractions is I get the common denominator quite easily here, because 1 can be rewritten as 2 on 2. So that's just 5 on 2 over 5. Now, 5 on 2 is the same as 5 halves. And if I've got 5 halves and I split them 5 ways, the answer will be a half. But I can do that the longer way. 5 on 2 divided by 5 is the same as 5 on 2 times 1/5, which is the same as 5 on 10, which is a half. Alright, so I know that m is a half. Alright, so let's just go and write down what we know. Y equals half x plus c, and let's get the intercept, and hopefully we'll confirm that it is 3. Alright, so I'm going to choose this point and sub it in, and that'll leave c as the unknown. 1 equals half times -4 plus c. 1 equals a half of that, which is -2 plus c. c equals 3. So now we can confirm that the equation is y equals half x plus 3. Alright, let's transpose this so it's in what we call intercept form. Alright, so what we're going to do, intercept form, we don't really like fractions in intercept form, so what we're going to do is get whole numbers for the a value and the b value. Okay, so the first thing I'm going to do with this is multiply everything by 2. Alright, and check out what happens. 2y equals 2x over 2 plus 6. Everything has been multiplied by 2. That cancels out with that, and now we've got whole numbers. Now I'm just going to transpose. That's -x plus 2y equals 6. Alright, so now it's in the form they want, which is x value first plus y value with these two numbers, the coefficients stated. Alright, we're going to grab the midpoint of those two lines. So remember what I said, girls, it's really important to sort of have a guess to know what a reasonable answer is. So I'm guessing 2, 2 1/3. Alright, let's see. Now, our values are -4, 1. I just got to write these down. -4, 1. And the other one was 1 and 7 on 2. Okay, now the midpoint can be found by just simply averaging the x values and averaging the y values. Okay, so that's x, y, and x, y. Okay, so what we're going to do is add the x values together. So we've got -4 plus 1 all over 2, which will give us our x coordinate of the midpoint, and 1 plus 7 on 2 over 2. Alright, so now that will be -3 on 2 as the x coordinate. Now over here, remember we've got 1 plus 7 on 2, that's 1 is the same as 2 on 2. So we've got 9 on 2 over 2. Alright, there's a simple way when I divide by 2, I simply multiply the denominator by it, but here's the maths. We've got 9 on 2 divided by 2, which is the same as 9 on 2 times a half, which is 9 on 4. Okay, so our midpoint is -3 on 2, 9 on 4. This problem here causes all sorts of problems because of the fraction, not the concept of midpoint. So my guess was -2, 2 and 1/3. I got -1.5 and 2.25, okay? Negative 1.5 is there, 2.25 is somewhere there. Very close, so I'm very confident that we're correct there. Alright, here we go. We're going to sketch these two graphs here. So we've got y plus x equals 0. Alright, let's transpose it. Y equals negative x. Alright, the gradient of this is negative 1. That means for every increase in the values of x, the y values go down by 1. Got no y-intercept. Okay, I can put it in plus 0, so it actually goes through the origin. Alright, and it's fairly easy. We've got a negative gradient, and starting at 0, 0, if I increase the x values by 1, we're going to go down one value, negative 1. Mark the point, draw the line connecting it, and there's our graph. Okay. Alright, that's difficult. A lot of students struggle with that problem, even though it's seemingly fairly easy. Alright, this one here, we've got a condition here. They want it sketched over this domain. Okay, that means that these points are the endpoints. Okay, they're called endpoints. Okay, in particular about these endpoints, this value here, 4, is included, which means when I draw the circle at the end, it's going to be filled. Why didn't that fill? I'll try it again. There we go. And this one here is not included because it's less than x greater than negative 2, so it's an open circle. Alright, so it's really easy to sketch this when we're asked to do endpoints. We use these as our guide. So we're going to sub in x equals negative 2 first of all. So we've got 3 times negative 2 plus 2y take 4 equals 0. Negative 6 plus 2y take 4 equals 0. 2y equals, that's negative 10, 10, y equals 5. When x is negative 2, the y value is 5. Okay, so let's mark that in. There's negative 2, 1, 2, 3, 4, 5. Okay, and remember, that coordinate point is not included, so we've got an open circle. Alright, now let's sub in this part of the endpoint. Okay, so when x is 4. So we've got 3 times 4 plus 2y take 4 equals 0. 12 plus 2y take 4 equals 0. 12 take away 4 is 8. That's going to be 2y equals negative 8. Y equals negative 4. When x is 4, y is negative 4. 2, 3, 4. 1, 2, 3, 4. That's it there. We're going to fill that in, okay, because it's included. Line joins the 2, and we don't go any further to the left and right. They're not asking for the intercepts, so we're not going to worry about them. And that's all we needed there to get the full 2 marks for that one. Okay, the very last problem, what we're going to do with this one here is we want to show that this line here, y1 passing through them, is perpendicular to this line here, y2, which passes through these 2 points. So it's fairly easy to do. What we're going to do is grab the gradient of this line, grab the gradient of this line, and show that it's perpendicular by multiplying the 2 together, and the answer should be negative 1 if that's the case. Alright, let's see how we go with that. Alright, now I can see just by sight that the numbers are a little bit unfriendly to do a by sight gradient check. Okay, so what we'll do is we'll just run the full y2 minus y1 over this one. So the gradient m of y1 equals 5 take 2 over negative 3 take 1. That's 3 on negative 4. M of y2 equals 1 take away negative 7 over 6 take away 0. y2, so that equals 8 over 6, which is 4 over 3. Alright, so now we're going to go m1 times m2, and it should be negative 1. We've got 3 on negative 4 times 4 on 3 equals negative 1. 3 4s are 12, 4 3s are 12, so I've got negative 12 on 12 equals negative 1. Negative 12 on 12 is the same as negative 1, so negative 1 equals negative 1. Therefore, we'll say y1 is perpendicular, excuse the writing, to y2. Alright, there you go, girls. There's the work solutions. Come and see me if you have any problems with anything that I've said and we'll sort it out.